In this lesson, we will find the least common denominator of rational expressions. Finding the least common denominator, also known as the LCD. So here are the steps. Step 1, factor all denominators completely. Step 2, if there are coefficients, find their LCD. Step 3, the LCD is the product of all different factors from each denominator, with each factor raised to the greatest power that occurs in any denominator. So here we're given two expressions, rational expressions, and asked to find the LCD. So first, let's look at the coefficients. And by the way, the LCD has nothing to do with the numerator, only the denominator. So into both denominators, we want to look at just the coefficients. So we have a coefficient of 9 and 15. And we want to know with 9 and 15, what is the least common number that they share in common? In other words, the least common denominator. So I need to go into the 9 timetables and into the 15 timetables to find the smallest number that they share in common. And here we see that the smallest number that these two numbers share in common is a 45. So in terms of the coefficient, 45 is our number. Now we need to look at the variables behind the coefficients. We just have one variable here, and that's a y. So what we want to know is, at most, what is the most amount of y's that appears in either denominator? So under the first denominator, we have 1y. Under the second denominator, we have 3y's. So at most, we have 3y's in either denominator. So put it all together. The LCD is 45, y to the third power. In this example, we're asked to find the LCD of a pair of rational expressions. So the first thing we need to do is look at the denominator and note the coefficients of each denominator. So the coefficient of the first denominator is 10. The coefficient of the second denominator is 15. So I want to ask myself, what is it that they share in common in terms of their multiple? I want to find the least common multiple among them. So that means I have to go into the 10 timetables and into the 15 timetables to find the smallest number that they have in common. And that number is 30. And so 30 would be our LCD. It's also going to include some variables, because if you look behind the coefficients, they have variables. We have two variables here. We have an m and we have an n. So the way you find the LCD with the variables, you want to know the most amount of times that variable appears in either denominator. So very important that you note it's in either, okay, not both. You want to know the greatest number of times it appears in one or the other. Okay, so let's start with m. I want to know at most what is the greatest number of times that m appears in the first denominator or in the second denominator. And I see that the first denominator you have 1m, and the second denominator you have you don't have any m's. Yes. Second denominator, there are no m's, so at most they share 1 m in common. Now let's go to n as in Nancy. So we're going to look underneath both denominators to find what is the most amount of time n appears in either denominator. So I want to look at the first denominator, and n appears at most once. Looking at the second denominator, at most n appears twice. So therefore, if we put it all together, the LCD includes 30, 1m, and 2 n's. And the way we would write that is 30m n squared, and that is your LCD of these two pair of rational expressions. In this example, we're asked to find the LCD of a pair of rational expressions. So here we're given rational expressions where the denominators are actually what we call conjugates. You have x plus 2 and you have x minus 2. Once you notice that your denominators are conjugates, your LCD will be the two of them together. Why? Because they're different. So whenever there's no coefficients involved, such as in previous problems, they've had coefficients, so you find the LCD of those two coefficients. When there isn't a coefficient and they're simply factors, binomial factors, then what you just want to know is what is the most amount of times each one of them appear. And if you just have the two of them, that means they only appear once. So together, both of them would be your LCD. So again, we have two factors, and those two factors are x plus 2, x minus 2. They both appear at most once. So therefore, when you put it all together, the LCD is the combination of both of them, which is x plus 2 times x minus 2, and that is the LCD of these two pair of rational expressions. In this example, we're asked to find the LCD of a pair of rational expressions. So looking at the denominator of these rational expressions, under the first one of 3x plus 15, we need to first factor that out so that we can see exactly how many different unique factors that we have. So let's take the GCF out. There's a GCF of 3 there. Once we take that out, we're going to write what's left in parentheses. And the second denominator is x plus 5 squared, which means you just simply have two of the same thing. So now that we have them factored out, we can see them readily. We can see exactly what we have in terms of our factors. So it looks like in terms of what are all the different factors, well, I only see two different factors. I see a 3 by itself, and I also see an x plus 5. There are no other factors. You can think of them as people, and you say, well, who's at the party? Or how many people do you have at the party? Well, the only people that are there are 3 and x plus 5. Nobody else is there. So we would say that we have two factors as 3 and x plus 5. And now we want to know at most how many times either one of them appears. And starting with 3, you want to know what is the most amount of times that 3 appears, and it's once, only once. And that's in the first denominator. Remember, it's either or. Next, we want to know how many times does x plus 5 appears. And I know your first reaction is to say you see it 3 times, but we want to know what is the greatest number of times it appears in either denominator, which means how many times do you see it under the first denominator? Well, I only see it once. How many times do you see it under the second denominator? Twice. So at most, the most amount of times that x plus 5 appears is twice. And so when we put that all together, our LCD then would be 3 times x plus 5 squared, because you have two of them, because it appears at most twice. And there you have it. That's how you find the LCD. In this example, we're asked to find the LCD of the following rational expression. So if you look at the denominators of these two rational expressions, they are trinomials. So in order for you to find out what are the unique factors that are involved in these two expressions, you're going to have to factor them. So let's go ahead and factor them. We're going to factor them into two binomials. And now that we have them factored, we want to look at all the unique factors. In other words, if we have a party and they are people who attended the party, who's at the party? Well, I see x minus 3, I see x plus 2, and I see a plus 1. Only 3 members, only 3 unique factors. So since we only have 3 new unique factors, the next step is to find out, okay, well, how many times at most in either denominator that these 3 factors appear. So looking at a minus 3, I see a minus 3 appears once in the first denominator, does not appear at all in the second, so we have a 1 for that one. A plus 2, I see it once in the first denominator and once in the second denominator. So at most in either denominator, still 1. So we have a 1 for a plus 2. A plus 1 does not appear in the first denominator, but it does appears once in the second denominator. So at most, it appears once as well. So since all 3 appears at most once, then all 3 are part of our LCD. So our LCD is a minus 3 times a plus 2 times a plus 1. Now, does the order matter as far as who is first? No, it does not. You can arrange them in any order as long as you have all 3 factors included in your LCD, then you're good. And there you have it, finding the LCD. In this example, we're asked to find the LCD of the following rational expressions. So if you take a look at the denominators here, you first may think that these are conjugates in the bottom, but no, they're not conjugates. What they are inverses of each other, or opposites. Under the first denominator, you have x minus 2, where x is positive and 2 is negative. Under the second denominator, the 2 is positive and x is negative, so they're very opposites of each other. So when that is the case, your LCD can be either one of them when you're solving your math problem. So the LCD can be x minus 2, or the LCD can be 2 minus x, whichever one you like to use. And there you have it, finding the LCD